So our first learning goal today states that I can determine if an equation is balanced. What does balanced mean? What do you think that? What do you think balanced, Danny?
Stable.
Pardon? Stable. Yeah. If it's balanced, it's stable. Is there anything on a playground that would describe balance? Sylvia? A teeter-totter. And for the teeter-totter to be balanced, what has to be true? Both sides have to be equal. What about both sides? What's on the teeter-totter? People, right? So their weight has to be equal. So they don't weigh the same, then you might need to add something to the lighter person's side so that it balances, so that it equals out, so that you can have that stableness, that balance. You can both be at the same amount of height off the ground, right? Okay, so we're going to be thinking about, let's just kind of think about like a teeter-totter. We're going to see, and our teeter-totter is our equation. And the equal sign is going to be, what do they call this thing in the middle? Anybody know the name for the middle of a scale where you do want to balance? I'm not a very good science student, so I don't. Anybody know it? I just want to call it, for some crazy reason, and I might be totally off, I want to call it fulcrum. Am I totally, like another world? I don't know. So we'll call it the base, we'll call it the stabilizer, we'll call it the equal sign, okay? So this little trapezoid that is below it is actually the trapezoid is what's going to be our equal sign, okay? So see how the equal sign is above it in this model here? So what we're going to do is we're going to have to simplify the numerical expression on each side. So we have a left side and we have a right side. We're going to simplify each of those expressions, and if each side simplifies to the same value, we can say we have a balanced equation. Okay? Or in other words, the scale is balanced. The teeter-totter is both ends of it are equal amounts off of the ground. So that one's just for a model for you to study on your own. You have another example to look at. Let's look at the first one we're going to do together. We have on one side of our equation, we have 54 minus 30 plus 40. That's one of our people on the teeter-totter. And on the other side, we have 8 squared. We want to know if this would be a balanced teeter-totter. Would this be a balanced equation? Would this be a balanced scale? Okay. So let's simplify our left side of the equation first. So 54 minus 30 plus 40. What's the first thing we're going to do here? Sierra? Add the opposite, even if you don't want to. Because when we add the opposite, now we can start thinking of it in terms of algebra tiles, or we can start thinking of it as we have some positives, we have some negatives, and what's going to happen. So now we have all additions, so now we're just going to follow order of operations. These guys are going to go first. So 54 plus a negative 30, 24. There's more positives than there are negatives. There's 30 negatives, so 30 negatives cancels with 30 positives. We have a positive 24 left. So we bring down our plus 40. What's 24 plus 40? 64. So the left side of our scale, our teeter-totter, whatever we want to call it, has become 64. Will you go put that up there on my little drawing? Okay, now we're trying to determine how about the other side. What does it simplify to? So what is, the only thing on the right side is 8 squared. What is that? Wait, it's 64. 8 times 8, that's what 8 squared means, right? 8 times 8 is 64. That's the only thing we got to do on that one. So we're going to put a 64 up here. Do we have a balanced scale? Do we have a balanced teeter-totter? Do we have a balanced equation? Yes, so we can put an equal sign there. We can say, yes, it should be balanced. It is equal. So let's put that in our notes. The scale is balanced. So that means, let you catch up. scale is balanced. So that means the equation is balanced. Because that's how they're going to ask it oftentimes in your homework is the equation balanced? So we are going to say the equation, let's underline that part, the equation is balanced. Okay, do we have another one on that side to do, or is that the only one? Only one on that side? Okay. Anybody have questions before we move on? No? Anybody need to catch up yet? Somebody need to do? Okay. The rest of you can move on and start looking at the next one if you want. Well, the first thing we're going to do is we're going to write down the expression. What's the expression, the numerical expression on the left? What's the numerical expression on the right? Because that's how we're going to show our work. So the left side has the expression 8 plus 7. The right side has the expression 40 plus 35. Anybody here already got a pretty good idea whether this equation is balanced or not? Yeah, you're adding two single-digit numbers together that are both positive. You're adding two double-digit numbers together that are both positive. Is it possible for this to be balanced? Probably not, right? Okay, what is 8 plus 7, though? 15. So that side becomes 15. And what is 40 plus 35? 75. So that side becomes 75. So can we put an equal sign there? No. This would not be balanced, would it? Which side would be down and which side would be up? 15 would be down and 75 would be up? Yeah, if you have somebody weighed 75 pounds, wouldn't they bring the teeter-totter down and the 15-pounder would be up there saying, hey! Yeah, okay, so we're going to put does not equal. Does not equal. That's how we show our equation is not, we can't say it is a true equation because 15 does not equal 75. So we are going to say the equation is not balanced. And that's a pretty big deal in algebra. We have to work with balanced equations. So if they're not, we have a problem. Okay, questions, anyone? Okay, showing everything that we have shown so far. I want you to try number 3 totally on your own. Go, show everything. So use the problem above as an example for you to show everything for this problem. Well, some people have already forgotten something that's there. Oh, good job, Sammy. Left, right, left, right. I know that is the left, and I know that is the right, where you're putting it, but let's identify them. Now, let's be reminded that with order of operations, we are not going to change subtraction to add the opposite until you've taken care of things like maybe parentheses and or exponents. Right? So, don't change this 10 squared minus 9 squared to add the opposite yet. Let's just do both of our steps of order of operation, which says, what is 10 squared, class? 100. We're going to leave it as minus, and we're going to write 9 squared. Because we're only going to do one thing at a time. We're not going to overdo our order of operations. It likes to take its time. Okay, and now we're going to do what next? 9 squared. So we're going to end up with 100 minus 81. But no, let's not call it negative 81 yet. Let's just say that 9 squared got replaced with 81. Now we will change it to what? Now we'll change it to add the opposite. So we're going to have 100 plus negative 81. What are there more of? More positives or more negatives? More positives. So our answer should be positive. And what is our answer then? 19. 19 we should end up with on this side. So we're going to circle that, and we're going to go up here and, oh, what else did you have to do? Draw a scale. So we're going to put our 19 here. Okay. 10 plus 3, is that what we're going to do first? Why not? Exponents have to come first, don't they? So we're going to do the 3 squared first. So we have 10 plus what, class? 6? 9. 3 times 3, not 3 times 2, right? And 10 plus 9 is? 19. So the other side of the scale becomes 19. Equal or not? Equal. Okay, we end up with the same thing on both sides, so we're going to put an equal sign there and say the equation, what? Is balanced. Question. Okay, let's look on at number 4. Wow. Do you think it's possible that the left side could equal the right side? What? Maybe. You know, we got a couple of double-digit numbers times each other. That should get a pretty decent-sized number, right? And we've got single digits only being multiplied on this side, so maybe it's possible this one's balanced. So what are we going to do? We're going to start simplifying. Left, right, the left side. Oh, that's the easy one, right? 25 10 times is 250. 25, tack a 0 on it, right? Okay, let's go through here and draw our scale. Well, now we have 5 times 2 times 5 times 2 times 5 squared. Okay. What's first? The exponent. 5 times 2 times 5 times 2 times 25. And now what? Let's go back to the beginning. It's all multiplication now, so let's just come back here and start going across, huh? 5 times 2 is? 10. Now what are you going to do? 10 times 5, okay. And that is 50, okay. And now what are we going to do?
50 times 2.
50 times 2, okay. And what's that? 100, okay. And what's 100 times 25? 2,500. So 25, tap 2 zeros on this time. 125 times is 2,500. So I'm going to go up and on the other side of my scale, I'm going to put 2,500. And what am I going to put in the middle? Is not equal to. Yep, is not equal to. And I'm going to say what?
The equation is
The equation is not balanced. That's right. Could somebody tell me what we could do on either the left side or the right side that would balance this equation? What do you think, Katie? Instead of 50 times 2, if this was 5 times 2 here, that would be kind of nice, wouldn't it? Okay, well then how can we make that happen? Because there's no 50 up here. I want to see if you, so it appears that you want to do something to the right side. So if we want 50 to become 5, what would have to change about that expression? You know, division what? Or would we have to divide by? Okay, so we would have to add a divided by 10 in here. If we added a divided by 10 at the end, don't do this on your papers, don't do this on your papers, it'll confuse your notes, okay? Just hang with me. If we did a divided by 10 there, that would mean we'd have one more step to do here, wouldn't we? Well, because all along here we'd have a divided by 10, and so I'm just going to add it down here at the last step because I don't want to write it that many times. What is going to happen now? I'm going to take 2,500 and divide it by 10, and I would get 250. Okay, so in your homework, here's what's really going to actually happen. Instead of you doing exactly what we were doing here, you're going to simplify one side of the scale, and then they're going to give you part of an expression and you have to figure out what do you have to put in that expression so that it will be balanced, so that you would have a balanced equation. There's some of that to do in your homework also. So we were analyzing here, what could we do to get this one to balance? We could divide the right side by 10. Or, what could we do if, that also would have been an option. What could we have done to the left side? Instead of doing this, what could we have done to the left side? Danny? Multiply by 10. If we took the other side times 10, so in other words, we're going to insert a times 10 in here, we would end up with 2,500, wouldn't we? Yeah, then it would be balanced, wouldn't it? Okay, anybody have questions? Remember I said don't throw those extra little things in there, it'll confuse your notes. So if you did erase them, like I just did. No questions? We have one more learning goal to attack here. You got this one? Okay, then don't look so, don't look so convincing. Okay, moving on then to our next page that is handwritten by Legrand. We're going to do our other learning goal, which says I can find a missing angle measure in a triangle. Okay? So it's not like the angle is missing, it's just its measure is missing. Okay, what can you tell me about the sum of the angle measures in any triangle? Anybody happen to know that little detail? First of all, how many angles are there in a triangle? 3. There's 3 angles in a triangle. Anybody know what those 3 should? What does sum mean? Addition, add up to. What should those 3 angle measures, 1, 2, 3, what should they add up to? Anybody have any idea? Okay. It's 180 degrees, yeah. So if you were thinking 180, you had it. 180 degrees. Give me a pen here. Everybody fill that in. The sum of the angle measures in any triangle, those 3 angles together should equal 180 degrees. So we are going to find the missing angle measure, and we're going to use a scale to do it, okay? So we have this triangle here that has an 80-degree angle, it has a 35-degree angle, and then there's the missing measure. It has another angle that's there, but we just don't know what it measures. And we said that they have to add up to what? 180. So on one side of our scale, what could we put? 180. Let's put that over here. That seems like a good spot for that. Let's let that be the right side. What could we put on the left side now then? 80 plus 35. But there's 3 angles, so we gotta have another plus, don't we? What should our third one be? X. We don't know what it is, do we? So we're just gonna put an X there right now. We need to know, what do we have to do to 80 plus 35 plus X? What do we have to do to that expression to get 180, which is on the other side? So anybody have any ideas what we might be able to do to help us get that X? It's probably going to take us a couple of steps. So do you have an idea of one step for me at least? How could I figure out, how could you figure out what that needs to be? Okay. That'd be kind of a good move, I think. If we took 80 plus 35, at least we know what 2 of them add up to, right? Wouldn't that be a good move? At least we know what 2 of them add up to. So what's that become? 115. Okay. So 2 of them together equal 115 degrees, but all 3 of them together have to equal 180. So what do you think we could try next? Wait.
Subtract 80 and 35.
Subtract 80 and 35? Could I make that just a little bit less work? You know, it's Friday. Come on, wait. Give me a break.
Use a calculator.
No, I don't use calculators. I break out in a rash. I can't do that. Idea?
Subtract 1.
So didn't we just figure out that 80 and 35 is 115? So wait, couldn't I make life just a little bit easier instead of having to subtract each of them? Could I do that? Thank you, it's Friday. Okay, go ahead. Subtract 115 from 180. I get 65. Anybody else get 65? Okay, awesome. Yeah. Okay, so what did we just find?
X.
We just found X, didn't we? Okay, so we are going to say then that, because that's what we were supposed to find, is the missing angle measure. So we're going to say that X equals 65 degrees. Which means then that if we substituted that X in, it better make our, what? Scale balance, our equation balance. So let's try it. So let's check it. $80 plus 35 plus 65, other side of the equation, 180. Well, somewhere along the line, we've already added these guys together, and that's our first move, isn't it? We already did that, so we're going to steal that. We're not going to suffer through it again. But have we added 65 to 115 yet anywhere? No, we did a subtraction problem to get it. So we're gonna have to add it. So I'm gonna come over here where I have some space and I'm gonna add those guys together. And I get 180. What do you get? 180. If we end up with a balanced equation, we can say we got the right answer. Did we get the right answer? We did, didn't we? We got a balanced equation. If we would substitute 65 in for the x like we did in our check it out problem here, that left side of our scale would become 180, the right side of the scale is 180. We got it. Okay, anybody want to ask a question about any part of that? Okay, we're going to do one more then, number 2. We have another triangle here, and we're supposed to find the missing angle measure. Is there more than one missing angle measure here? Yeah, I see 2, don't you? I only see one. It says 40 degrees. That's the only information they've given us. How is that enough? Sylvia? There's a square in the what? In the top left-hand corner? Oh, when you have a little square here like this, that means you have a right angle, and a right angle is a 90-degree angle. We actually do know that one. Whenever there is so maybe you want to put this off to the side here. This is called a right angle, and it equals 90 degrees. Whenever you see that marking, you can count on that. They shouldn't even have to tell you it. They're going to be like, nope, this is something you need to know yourself. Okay, so what are we going to put on our scale? Derek, give me an expression for one side or the other. You get to pick which side.
We go left.
Okay, what am I going to put over there?
90 plus 40.
90 plus 40, okay. That all I'm going to put?
No.
What else do I need? Triangle. It has how many angles again?
3.
3. Do you want to phone a friend? He can get his hand up.
Yeah. 90 plus 40 plus x.
Plus x. There's our third angle. We have to call it x for right now. It's there, but we just don't know how much it measures, right? Okay, what's going to go on the right side of our scale? Sammy? 180. Those 3 better add up to 180 because they form a triangle. So we're going to do what? What do you think we could do? What's something we could actually do here, Danny?
180 minus 90.
You're going to take 180 and subtract the 90. Okay. She says, you know what? I don't care if it's Friday or not, Brand. You're going to work. You're going to do it my way. Okay, so I will. Oopsie, I didn't mean to cross that out. Undo writing. Okay, put in 1 there. Okay, 0, 9. Okay.
Plus 40. Minus 40.
Oh, so now we got to do another minus. Okay, well, that's cool. And what's that? 50. Okay. So, could you explain to us, Danny, why we're subtracting and subtracting twice?
Because 40 plus 50 is 90, and 90 plus that is 180.
So you're telling me that we're trying to get to the 50.
Because 50 plus 90 is 180. 50 plus 90 is 180. 50 plus 50 is 90. 90 plus 90 is 180. 50 plus 50 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 is 180. 50 plus 50
what you did, I just am trying to, figure out, how can we explain to the others around here why we subtracted, because what did we do last time? We added the two together that we had, and then we took that total away from 180. So Danny's taking us down another path. Is it okay to go down another path? Yeah, Kaden says, okay. Kaden, you want to help?
I think we subtracted twice because 90 plus 40, or 90 minus 40 is 50. And then 90 plus 40 is 113, or 130. So take 130 plus 50 and 180.
Yeah, I got a lot of working backwards going on here. And it's cool. I mean, it's totally cool. Got some thinking going on here. Yeah, so it's kind of like, when we did it up here, we figured out how much we had all together already, and then we subtracted it from the 180 because we needed to figure out how much was left, didn't we? So really what's just going on here is instead of doing both of, adding together and then subtracting, it says, we know that one of the angles of that 180 is 90 degrees, so we'll take that away. It's used up that much. And now we got two angles left that equal 90. So now we know that one of those angles is 40 degrees, so now we'll take the 40 away from the 90 that's left, and we get 50, which leaves for us exactly what our x value should be. This is our third angle. So we are going to say x equals 50 degrees. We just went about getting it a little bit differently. Here's what you were all kind of almost doing here. You're almost doing the check problem already, okay? So let's do check it. Let's check it. So we get a 90 plus a 40 plus we just decided that the x should be 50 and the other side of our equation is 180. So we're just like saying, okay, we're dumping a 50-pounder on here and we're going to see if it'll balance our teeter-totter. So what are we going to do first? 90 plus 40. What's 90 plus 40? 130. Okay. What's an easy way to add 90 to 40 without having to line them up and do digits and all that fun stuff? Like, yeah, add 9 plus 4, and 9 plus 4 is 13, and then we tack a 0 on because they were tens, weren't they? Yeah, they were numbers of tens. So 13 tens we have here, which is 130. Now what are we going to do? Now we're going to add the 130 and the 150 together. And 13 plus 5 is? 18. And those are 10, so we're going to tack on a 0. Oh, that's a cool color. Okay, so I got 180 on the left side. The right side already was 180. Did we get a good answer? We sure did. We are good, aren't we? Okay. Questions? You got this? Second learning goal also? Okay, then you go ahead and get out some loose leaf. Don't put those notes away. Keep those notes out. I'll go crazy if you put them away, like I'm already starting to do. Get out a sheet of loose leaf paper, please.